Hey guys, welcome back to our bit manipulation series. So in this bit manipulation series we have covered the theoretical part, which is basically the solid foundation that is required to start solving problems using bit manipulation. If you have not watched that video, you can watch the video in the bit manipulation playlist. From this video we will move from theoretical knowledge to practical application, and we will start solving some basic problem. So these problems are very easy, but it will help us build our foundation much stronger, and later on we will move to much bigger and more complex problems. So let's start with the problem, and the problem statement is find if a number is even or odd. Okay, so the question is find if a number is even or odd. Okay, I know many of you are already familiar with this question, and it can easily solve by using arithmetic operations like modulo operations. But we have picked this question to understand how we can solve such problems using bit manipulation as well. So why this question? See, arithmetic operations is much slower as compared to bitwise operations, okay, or bit operations. So that's why we have picked this question. The second thing is, like, it will help you build the intuition of using bit instead of arithmetic operations. Okay, so let's understand first that how we are solving this problem using arithmetic operations, and later on we will understand how we can solve this using bitwise operations. So let's say we have a number 4. Okay, so to know whether the given number is an odd or an even number, we perform modulo operations. Let's say the modulo operation is denoted by this symbol. Let's say if we perform a modulo operation of the given number with 2, we are getting a remainder of 0. So if you are getting a remainder 0, it means that the given number is an even number. And the same operation if you are performing with an odd number, and if it is returning you 1, then the given number is an odd number. Okay, this is very easy one line answer. Okay, and I know most of you already know this solution, but now how we can solve the same problem using bit manipulation. So here, as we know, in bit manipulation we deal with bits. So let's take the same example, 4. Now if we see, the binary representation of 4 is 0 1 0 0, correct? So the binary representation of this number is 0 1 0 0. If you observe here, this is an odd number and the binary representation is ending with 0. Let's take one more example. Let's say 10. As we know, 10 is an even number, and the binary representation of 10 is 1 0 1 0. If you see here also, the number is ending with 0. Similarly, let's take few more example, but for odd numbers. Let's say take 7. If we take 7, the binary representation of 7 is 0 1 1 1, and this number is ending with 1. Okay, let's take one more example, 11. 11 binary representation is 1 0 1 1, and this number is also ending with 1. So from these examples, what we can observe is the even number is ending with 0 in their binary representation, and the odd number is ending with 1. So this observation we can use to solve this problem. Okay, but in real life problems we are not going to get the binary representation of a number, and we cannot observe that number directly to get the desired output. Okay, in real life we will get the numbers like 4, 10, 7, 11, and we have to perform certain operation to know what is the last bit of that number in their binary representation. So knowing this much is not enough. We have to perform certain operation, and that operation is going to be performed using bitwise operators to know what is the last bit, whether it is a set bit or a not set bit. So if you observed, even number is ending with 0, odd number is ending with 1. So what operation we can perform? Let's take the first bitwise operator that we know is an AND operators. Okay, what is the rule in AND operators? The rule is AND operator is if there is a two number a and b, if both number is not set bit, then AND operation we will get a not set bit. If any of the number is 1 and the other is 0, then also we will get 0. If this is 0, this is 1, then also we'll get 0. We will get a set bit only in one condition, that is if both the bit is a set bit. Okay, now we are going to use this property to solve this problem. How? Now let's say we have a number 4, its representation is 0, 1, 0 and 0. Now if we perform an AND operation of this number with 1, okay, if we perform 4 AND operation 1, what we will get? Now the binary representation of 1 is 0, 0, 0 and 1. If we perform AND operation of this number, we will get 0 here, as the remaining all digit is 0, so the entire number will become 0. So in result we will get 0. So the AND operation of 4 and 1 is 0. Similarly, if we do for 10, it is 1 0 1 0, as this number is an even number ending with 0. And if we perform AND operation of 1 with this number, you see what we will get, as this last bit is a not set bit, and any operation it will perform with not set bit and a set bit, the AND operation will always going to return 0, as the remaining value is 0, so all the remaining values will be 0, so it is again returning 0. So what we can observe here is that any even number AND operation with 1 is going to return us a result is 0. So what it will return if you perform let's say AND operation with an odd number. Okay, so the same example we will take 7. So 7 is represented by 0 1 1 and 1, and we are performing AND operation of 7 and 1. Okay, so here 1, again the same number, and AND operation, as the last bit is 1 and the last bit of 1 is also 1, so if we perform this AND operation we will get 1, as the remaining bit is 0, so all the remaining number will get 0. So in output we will get 1 as a result. Let's understand this with one more example of 11. 11 is represented by 1 0 1 1, and same we are performing AND operation of with 1 and 11. So again, if you can see, only the last bit is a set bit, and if both bits are set, it will return us 1 and the remaining value will become 0 automatically, and the output that we are getting is 1. So from this calculation and from this observation we can conclude that if we are performing an AND operation of 1 with any even number, it is always going to return us a 0, and if we are performing an AND operation of 1 with any odd number, then it is always going to return us 1. So this AND operation, by performing this simple AND operation, we can find out whether the given number is even or the given number is odd. So I hope you have understood this way of solving the problems, like how we have observed this bit positioning, and how we use bitwise operators to get the output. Now it's a very easy code for this. I will use C++ language to write code for this. Let's say we have a function. Let's say we have a void function and a number given is n. So it's very easy. Anyone can write if the given number and it is performing an AND operation with 1, and if it is returning us 1, in that scenario the output will be odd, else the output will be even. It was a very small and simple problem, and I hope you have understood the solution and the approach that we have followed here. The notes and the detailed code in all different language, you can visit the link in the description. Similarly, we will solve more such problems in our upcoming videos. I know these are easy problems, and you might be thinking that why we are investing so much time in solving such problem which we can easily solve using other approach. But believe me, it will help you build your foundation, and that will help you solving much more complex problems. So thank you guys. I hope to see you in the next video. Bye bye, take care.